This is AP Calculus AB. We are on self-check 3.4. In number 1, we're asked to find where are we decreasing. So first, you need to find the definition of G decreasing, and the definition of G decreasing is G prime is less than 0. Now that I know that definition, I know I need to find G prime. There's G right there. We need to take its derivative. So G prime of x is going to be equal to, remember that this power 3 is going to come down in front, multiply by the 1/3, and cancel out, leaving just behind x. We are going to go down a power from 3 down to 2, and then we move on, plus. All right, again, this 2 is going to come down in front. These 2's and 2's are going to cross cancel, leaving behind the 3. This is going to be 3x to no power, and then again, the derivative of a linear is just a constant minus 70. All right, we have our function ready to go. We're going to set it equal to 0, but before we do that, I want to factor it a little bit. This is going to factor as x plus something, x minus something. I know that I have x plus something and x minus something because when I multiply a positive by a negative, I get a negative. I have to think of factors of 70, and one of the factors of 70 is 7 and 10. Therefore, I'll say 7 and 10, and I have it all factored. And now I will set that equal to 0. When I set it equal to 0, I will get x plus 10 is equal to 0 and x minus 7 is equal to 0, and that will give me x is equal to a negative 10 and x is equal to a positive 7. Setting up our sign chart over here, I will have a point over here at negative 10, a point over here at 7. Those are both my critical values that I label. And then from there, I'm going to figure out where I'm positive and negative. The quickest way to find that is to look at the leading coefficient whenever it's in standard form, aka the number in front of the variable with the highest degree. That variable, that coefficient, is positive. Therefore, the right-hand behavior will match the same sign and will also be positive. And then I'm looking at our powers for those linear factors. Those powers are odd numbers. They're technically 1. Therefore, it will switch whenever we do the leapfrog method. It will switch and then switch yet again. Therefore, we have a negative and then switches back to a positive. So we have our sign chart all complete, and we can come back and answer where are we decreasing, where is G prime negative. G prime is negative right there. We can highlight this interval right here, which is all the values between negative 10 and positive 7. Negative 10 to positive 7 is D. All right, and number 2, we're looking for which of these extrema are correct. And I know that the word extrema just means minimums and maximums. It's really asking which of those 3 are correct. I'm noticing that in the factored form, it already took the derivative for us, which is really nice because a maximum happens where f prime goes from a positive to a negative. A minimum happens where f prime goes from a negative to a positive. So we already have f prime. We're looking at the powers. I'm noticing that when I have an x minus 3, it's to a power of an even number. Therefore, this one will not change signs. However, this x minus 2 and this x minus 4 will change signs because I have an odd degree and another odd degree. So I know that this positive 3 is incorrect. It will not be a minimum. It will not be a maximum. It will not be an extrema because it does not change signs. To figure out if these 2 are correct or incorrect, I don't know if it's a maximum or a minimum. We do have to make a sign chart. When I look at my sign chart, I know that I'll have x is equal to a positive 2, positive 3, and positive 4 in order to make each of those 0. So I will have a positive 2, a positive 3, and a positive 4. Technically, those are all critical values, so I can label them critical values. But I noticed that this 3 came from this factor, which had an even degree, meaning I'm going to cross this one off, and it's not going to change the sign. I'm looking at the right-hand behavior, asking if it's positive or negative, and to do that, I'm looking at the leading coefficient. I don't see any coefficient, so that coefficient is actually 1, aka a positive 1. Therefore, the positive is our right-hand behavior. Every time that we leapfrog over, we will change signs. Whenever we have an odd power, these will change to a negative. This one will not change signs, jumping over the 3 because it came from an even degree. That's why we cross it off. So it will stay negative, and then when we leapfrog over again, we will get a positive, and we have our sign chart complete. I'm noticing that at 2, I should switch from a positive to a negative for my f prime because that's the definition of a maximum, and indeed it switches from a positive to a negative, so this one is correct. We already know this one is incorrect because it does not switch signs from a negative to a positive for a minimum because it does not change signs whatsoever due to our even power. But for our critical value of 4, to be a maximum, it should be going from a positive to a negative, but it goes from a negative to a positive. If it had said minimum here, it would have been correct, but it says maximum. Only 1 is correct. Therefore, the correct answer is A. In number 3, we are asked to find where we are concave up. The definition of f concave up is where f double prime is greater than 0. So we need to first find f double prime. I only have f, therefore I need to take the derivative not once, but twice. When I look at f prime of x, I get 3x squared minus, okay, let's be careful here. The 2 comes down in front. 2 times the 6 is a 12, and this is going to be x to the power of just 1, and I'm not going to write that 1. It should be right there, though. All right, that's the first derivative. Let's take the second derivative, f double prime of x. And that's going to be, again, 2 comes down in front. 2 times a 3 is a 6. And x goes down to a power from 2 down to 1. And then the derivative of a linear function is just a constant. Therefore, this is going to be minus 12. While this is good enough and I can set this equal to 0, I like going a step further and factoring out the greatest common factor. I can factor out 6 from each of these, meaning 6 is factored out, leaving behind, 6 is gone. And that's going to be x here. And then 12 divided by 6 cross cancels down into a minus 2. Again, I'm copying that minus sign over here for that minus sign. I have it all factored. I will now set this equal to 0, meaning x is equal to positive 2 is one of my answers, because again, 2 minus 2 gives me that 0. So when I set up my sign chart will only have one potential inflection point at 2. You can call that a potential inflection point if you want. I usually just leave it blank. Is it inflection point? Well, I look at the power up here. There is no power, therefore the power is 1, and 1 is an odd number. Whenever you have an odd number, it will switch signs. What sign will it switch to? Well, the leading coefficient is positive, therefore the right-hand side is also a positive, and it will switch signs when I leapfrog over to the left-hand side, and it is a negative over here. So where is it concave up? It's concave up whenever f double prime is greater than 0, whenever f double prime is positive. This is a sign chart for f double prime, and it's positive over here to the right of 2. How do we say to the right of 2? We say x is greater than 2. The correct answer here is A. In number 4, we're asked to find a point of inflection. So points of inflection are wherever we have f double prime sign change. Sign, and I ran out of room, change. So we need to find f double prime. The definition always leads me on what I'm supposed to do. I only have f. Taking the derivative once will give me f prime. F prime of x will be equal to 15x to the power of 4 minus 20x to the power of 3. I don't want f prime, I want f double prime to see if I have an inflection point. Therefore, I take the derivative yet again, and I get 60x to the power of 3 minus 60x to the power of 2. And while I could set this equal to 0 and solve, I want to factor it a little bit more. I'm going to look at the greatest common factor. What can I divide both of these by? I can divide both of them by 60, and I can divide both of them by x squared. So factoring out that 60x squared, will leave behind, okay, 60s are gone, x to the power 3 divided by x to the power 2 is just x, and this all cancel out, leaving behind just a 1, so I'll say minus 1 here. And setting this equal to 0 means I'm going to have x is equal to 0 from this quadratic factor, and then this linear factor will give us x is equal to a positive 1. So we have two different values on our sign chart. We have a value at 0 and a value at 1 for a potential inflection point for pips. Which of these are actual inflection points? Well, we need an odd power in order to change signs, and we are asked to find where we have a sign change. So this 0 will not change signs because it came from a factor that was a power of 2. Therefore, I can cross this one off and say that one was not an inflection point, and this one is indeed an inflection point because we had a sign change due to its odd power. Therefore, we have an inflection point at 1. Correct answer here is C. All right, in number 5, we are asked to find, it actually gave us the first and second derivatives already. Which of the following must be true? It's asking about increasing, decreasing, and concave up, concave down. This is first derivative test. This is second derivative test. Luckily, they gave us the first and second derivatives. There's not very much room to work here, but let's see what I can do. For the first derivative test, that's called the f prime test, I can look at a sign chart. And for the second derivative test, I can also look at a sign chart. The first derivative test, I'm going to set both the top and bottom equal to 0. Well, you can kind of do that in your heads, right? Setting the bottom equal to 0 means x is equal to 0, and therefore x is equal to 0, we'll say right here, is a critical value. And then I set the top equal to 0. And that's a little bit harder to do, but in order for this to be equal to 0, you need to know your properties of logarithms. One of the things that you can plug into our natural log function to get it to 0, and the only thing you can plug in is 1. The natural log of 1 is equal to 0, therefore our other x value over here is 1, and that is also a critical value. Knowing where this thing is positive and negative is really important. The first thing that you need to know is that a natural log function looks like, and let's go ahead and draw a chart down here. It looks kind of like this, where this area on the left-hand side is no man's or no woman's land, meaning you cannot plug anything in that is negative. But if I plug in the number 1, just like we saw before, the value of 1 will be this x-intercept right here, and anything to the left of that will be underneath the x-axis, anything to the right of that will be above the x-axis, therefore positive. So in between 0 and 1, we're talking about this region down here, which is negative. It's supposed to be a negative, and everything to the right of 1 will be positive. And I realize I'm skipping a little bit. I kind of ignore the fact that we're dividing by x, but notice that everything to the right of 0 is everything that's positive, therefore x will always be positive, and I can kind of ignore the denominator here. So I'm looking and I'm seeing, well, f prime is negative between 0 and 1, so it's decreasing, f is decreasing between 0 and 1. So I'm going to say, oh, it doesn't have that option. It's always asking about, you can see over here, what happens when x is bigger than 1. When x is bigger than 1, we are positive. Therefore, we should be increasing and not decreasing. Incorrect, incorrect. It's not A, it's not B. What is E saying? F is increasing between 0 and E. Well, whoa, whoa, whoa. That's E is not even on our F prime test, which means that is also out of the running. Cool, it's now just a coin flip, a 50-50 shot of between C and D. The only difference is, are we concave up or down for greater than E? So let's go ahead and look at the second derivative test. For the second derivative test, we have to look at F double prime. We're going to set both the top and bottom equal to 0. When I set the bottom equal to 0, x squared equal to 0 is going to give us x is equal to 0 when we square root both sides. Therefore, x is equal to 0 is a potential inflection point. I can come down here and say at 0, we have a PIP, a potential inflection point, which is kind of like a critical value in the second derivative. The next thing that I need to do, which is a little bit harder, and I need to set the top equal to 0. So to get the top equal to 0, I need to do 1 minus 1, which means this natural log of x needs to be 1. How do you set natural log of x equal to 1? Well, natural log of e is equal to 1, therefore x must be e. And I can come over here to my sign chart and say e is a potential inflection point. Potential inflection point. My stylus is having some weird issues, which is why it's writing all stuttery here. And then from here, I only care what's happening to the right of e because this is all saying when x is greater than e. So what's really happening over here when I have a number bigger than e? So a good little test point to plug in over here would be something like e squared. Or e to any higher power. You'll see why that's a nice point. You can plug in like 4, but I don't really know what the natural log of 4 is. So when I plug in e squared, which is bigger than e, into our top, and by the way, the bottom is always positive because anything squared is positive as long as we stay out of the shadow dimension, but we never touch the shadow dimension in AP Calculus AB. So in e squared, plugging that in, I'm going to get the natural log of e squared. The 2 is going to come down in front, and the natural log of e is going to cancel out, meaning this whole thing is just 2. And 1 minus 2 is negative, therefore this entire interval over here is negative. We want to say that e is negative, or it's concave down because we have a negative value. The correct answer here is C. That does conclude Self-Check 3.4 for AP Calculus AB. Thank you for watching.